In the world of global travel, airports worldwide have a few things in common. Busy terminals filled with passengers and busy runways welcoming a constant stream of incoming aircraft. A plethora of safety concerns exist when it comes to air travel, and rubber buildup on the runway left by rapid acceleration of landing aircraft wheels are among the most important. This rubber buildup leads to decreased friction, and when left uncleaned over time, will prevent very slippery surface, particularly in wet conditions. Although a variety of methods are employed to remove these rubber deposits, none of them are more effective than the method of high-pressure water blasting. In the global community of water blasting equipment manufacturers for runway rubber and airfield paint marking removal, there are two very distinct methods in which the water blasting process is executed on the runway surface. The traditional method of movement is a lateral method of removal. With this method, a 10-inch wide cleaning head moves on a lateral mounted track across the front of the supporting vehicle as the vehicle moves slowly down the length of the runway. The backward movement of the blasting head attempts to directly correlate to the forward movement of the vehicle. However, here at Water Blasting Technologies, we have popularized a much different pattern of removal known as the linear method. With this method, the cleaning head or cleaning heads moved in a fixed position down the entire length of the runway in the exact same direction as aircraft land. Let's take a few minutes and consider the two methods, including the advantages and the limitations of each. Here you can clearly see the reality of each method. First, you can see the lateral method, which is moving a 10-inch blasting head in about a 6.5-foot wide pattern. Secondly, you will see the linear method, which moves the entire length of the runway before turning around and coming back from the other direction. Now let's take a closer look at the lateral method of removal. Remember, in this method, we have a 10-inch blasting head moving in a lateral pattern back and forth across the front of the vehicle as the vehicle moves linearly down the runway. This pattern leaves an overlap in between each of the corresponding tracks. According to our research, this overlap usually is 2 to 4 inches in width. If you do the math, an average rubberized area being about 2,000 feet in length, and the average overlap being about 2 inches in width. So if you take a 10-inch blasting head, reduce it by 2 inches, that means an effective blasting pattern of 8 inches. You take the 2,000-foot long rubberized area, multiply it times 12 to get inches, and then divide it by 8. This means that for each linear pass of a lateral tracked machine, there are 3,000 of these lateral overlaps per linear pass. So consider this. As this 10-inch head moves to the left and then to the right, assuming a 2-inch overlap, that would be 0.16 square feet consumed in an overlap as the unit travels from left to right. If the blasting width is 6.5 feet in the track, that would mean for every movement across, there's 1.08 square feet wasted due to this overlap. Assuming a runway is 2,000 feet long, there will be 3,000 such overlaps per linear pass of this tracking. If that's true, there's 3,256 square feet wasted per linear track. And since we've already discussed the fact that there are about 7.7 linear passes on the runway, the lateral overlaps on an average end of a rubberized runway would result in a net wasted overlap area of 25,000 square feet. Now let's talk about linear passes. It is true that the lateral tracking machines have fewer linear passes to complete. In fact, a lateral tracking vehicle requires only 7.7 or 8 passes per 50-foot wide area. However, as you'll notice, the lateral tracking vehicles leave a scalloped edge down the side, and when it comes back to do the next pass, the points of these scallops are opposing one another. The vehicles move so slowly that they're difficult to steer at that speed, and so it's necessary to take a much wider overlap, and the minimum that we've ever seen possible is 8 inches. If you take 8 divided by 12 so we can calculate square feet, that results in a square footage of 0.67. If we multiply that 0.67 times the length of the rubberized area, which is 2,000 feet in length, this results in a net overlap per linear pass of 1,333 square feet. We take the 1,333 multiplied times 7.7 linear passes necessary to cover the area, results in a net loss of 10,256 square feet. If we then add the wasted overlap area caused by the lateral passes, 25,050 square feet, to the wasted area caused by the linear overlaps of 10,256 square feet, results in a net loss of overlaps of 35,306 square feet out of a possible 100,000 square foot area to be cleaned. This means that a lateral machine operating under these parameters would be only 65% efficient. Now let's take a closer look at the linear method of removal popularized by water blasting technologies. A few clever innovations have made this method far more efficient than the competitive method of lateral movement. First off, let's take a look at the blasting heads. In this setup, you'll notice 2 blasting heads instead of 1, and a width of anywhere from 28 to 40 inches of removal width. In this particular case, we have 2 21-inch blasting heads married together for a total of 42-inch blasting width. However, a 2-inch overlap is required. Notice the overlap is far less than the 8 to 12 inches required by our lateral machine. How is this possible? First of all, the vehicle is traveling very quickly when compared to a lateral movement machine. Secondly, there are no scalloped edges left by the machine as it travels in a straight pattern. To make this truly understandable, you need to understand something about the blasting pattern and the circles in which the spray bars are moving in. There's jets all along the continuum of the spray bar, but the jets at the outer edge of the spray bar are traveling at a much faster speed than the nozzles on the inside of the spray bar. And what we do to mitigate the overlap is we put a diameter in the outer nozzles, half the diameter of what they need to effectively clean the surface, so that when the nozzles overlap in the middle, they're effectively cleaned only once, not twice. Therefore, as the machine travels, you'll see on the animation that the outer edges are only half cleaned, not fully cleaned. When we overlap the second time, that area is fully cleaned, and the area of actual overlap is very, very minimal. For the purpose of our mathematical calculation, we're going to use a 2-inch effective overlap, even though we would argue that such overlap really doesn't exist at all. If the average rubberized area is 50 feet wide, and we use 2 21-inch spray heads married together for a total of 42-inch blasting pattern, you notice that the effective blasting area is 40 inches in width. Now note that the water blasting technology's linear way of thinking, the blasting heads never travel in a lateral direction, thus completely eliminating any lateral overlaps. Assuming a 50-foot wide rubberized area and 2,000 feet long rubberized area, And assuming a 40-inch wide blasting pattern, 15 linear passes are necessary down the runway to clean the rubberized area with the linear technology. If we take a 2-inch overlap, divide it by 12 to come up with feet so that we can calculate square feet, you'll see that 0.17 multiplied times the 2,000 feet distance results in 333 square feet wasted due to overlap per pass. We then take that 333 square feet, multiply it times the 15 passes necessary, and you quickly calculate that there is 5,000 square feet wasted in overlaps on an area of runway to be cleaned. Compare that 5,000 square feet with the 35,306 square feet represented by the laterally movement machine. Now, there are two things to consider when talking about these overlaps. One of them is efficiency. Another of them is impact to the surface. True enough that water jets can clean a surface and do so and create very little to no impact to the surface. However, if you leave that machine sit in any area for any length of time, it will most certainly damage the runway and remove aggregate and bitumen from that surface. So this much can't be argued with. The fewer times you pass over that surface, the better off you are. Just as important is the efficiency of the machine. How fast does the machine clean the surface? If you're passing over areas 2 and 3 times, it doesn't make any sense. So the linear method creates less opportunity for any damage to occur, and secondly, it increases the speed at which you're able to clean any given rubberized area. Everybody understands on some level that horsepower is capacity. The higher horsepower you have in your car, the faster you can go, and the less time it takes you to go there. The more horsepower you have in your lawnmower, the wider path you can cut, or the taller grass you can cut, or the less time it's going to take you to mow that grass. Water blasters are no different. The most popular model of the Stripe Hog runway cleaning system utilizes a 12-gallon or 45 liters per minute. This is double the capacity of our competitors, and there's one clear reason why. Remove more rubber in less time. In fact, you'll find that our advertised removal rates are nearly 3 times that of our competitors. The reason is clear. By having more horsepower on board, we're able to push more water out the nozzles and clean more area in the same amount of time. You also notice that instead of one 10-inch wide head, we're able to have 2 21-inch wide heads and power those heads effectively because we have so much water moving through the nozzles per minute. This is a very important fact. Lateral track machines advertise 800 square meters per hour. We have proven the world over our ability to remove 1,800 square meters per hour. There are 2 reasons for that. Increased horsepower capacity resulting in the ability to clean more area faster. Secondly, the elimination of overlaps that we've discussed previously means that our cleaning operation is that much more efficient. Thirdly, let's talk about water consumption. We do use more water per minute, but do we use more water overall? The answer is a resounding no. Because our unit is more efficient than laterally movement machines, we actually use less water. Do the math for yourself. Use their advertised removal rates of 800 square meters per hour and 6 gallons a minute. This will result in 0.45 gallons used per square meters cleaned. Consider that with the linear technology. Use our advertised removal rate of 1,800 square meters per hour and 12-gallon minute consumption. And you'll quickly calculate that we use only 0.40 gallons per square meter cleaned. But wait, there's more. Water Blasting Technologies is the first company in the world to reuse water in a 40,000 psi or 2,800 bar condition and recycle it right back through the blasting head. For well over a year now, Water Blasting Technologies has been producing water recycling units and sending them around the world. You'll see here a unique patented process that allows us to take in fresh water, run it through a series of filters, and then through some very clever processes and inventions, we recycle that water straight back into the clean water tank and lose only about 200 gallons per day to evaporation and efficiency loss. We've run machines for over 2 weeks without ever changing the water in that machine. This is very important when you're talking about very short work windows on busy runways. How much more importance can be given to achieving that extra couple of hours traditionally lost to going to the fire hydrant and filling with new water? It's huge. Furthermore, consider the environment. Yes, we do have a great filtering mechanism that filters out and dries our rubber debris prior to dumping. But consider now, not only is that dumping not necessary, we're not using more water to begin with. Water can be a very precious commodity in parts of the world, such as Australia and other places where water is in short supply. So make sure you give adequate consideration to this important point. Fourthly, let's talk about visibility. When you're blasting a surface, conditions are always changing. Rubber is far heavier on the inside of the runway, far less heavy on the outside. You want to always be able to adjust to the ever-changing conditions present. Visibility before the blast head is important to establish your path that you're running on. Visibility after the blasting head is very important because you need to see the area that you've cleaned in order to establish whether you're moving too fast or whether you're moving too slow. Take a look here at how impossible it is to see what you've blasted on the laterally tracking machines. And then conversely, take a look at how easy it is to see the surface immediately in front of and immediately behind our linear way of thinking. Let's talk about versatility, the ability to adjust your speed when rubber is less present. Towards the outside of the rubberized area, rubber marks are often non-existent or very, very thin. When you have a laterally tracking machine, there's no ability to speed up. The forward speed of the vehicle is limited to where the rubber is heaviest across that lateral track. Whereas with a linear, every 40 inches, you're given another opportunity to increase or decrease your speed according to the thickness of the rubber. Wherever there's runway rubber to remove, very often there's some paint to remove with it. What about the ability to adjust blasting width for painted lines? Our easy quick change head system means that we can adjust from 6 inches clear on up to 42 inches in mere minutes. What about double yellow lines? We can remove a double yellow line while leaving the space in between untouched. Once again, 2 issues. We're leaving the space in the middle untouched so that we're not exposing that area to any possible impact from the high pressure water. And secondly, of course, we want our power positioned where it's making a difference and making us money, removing the line. Not hitting areas unnecessarily that don't need to be impacted. No. On a lateral tracking machine, if you have yellow lines to remove, the machine goes back and forth all the way across the lines, unnecessarily impacting the surface and wasting precious time and energy. Thirdly, for maximum flexibility, we offer the Hog Rider. This zero turn radius tractor is able to go 6 floors up in a parking garage while the truck sits down below. It can tether nearly 400 feet from the truck. It can do turn arrows, stop bars, gate areas, numbers, letters. With a stripe hog, there's never a trailer required. Trailers are cumbersome, dangerous, require extra room to maneuver. Further, consider that our blasting head never needs to be removed. Removing a blasting head and repositioning it's extra time, and again, creates unnecessary danger. How about our dewatering and easy dumping system? There's no sludge, no mess. What about the fact that our blasting pump requires no torque wrench whatsoever? It's so simple, so easy. Even you can use it. About the fact that our nozzles are very easy to check, even from the driver's cabin. Just pull the heads up, turn them around, stop your rotation, and immediately inspect whether your jets are sharp or whether they're worn. And how about this? A stripe hog is smooth. It goes down the runway with no shaking whatsoever. In fact, if you operate a lateral tracking machine for any length of time, it's been said that you may turn into one of these. We've placed more machines around the world than our two closest competitors combined, despite the fact that we've been selling them for less than half the time. The stripe hog was born in a contractor's shop, my shop. In fact, we're fond of saying around here our equipment was built by a contractor for the contractor. It's been forced to reckon with the real-time results produced by everyday rugged use. In fact, my 10 trucks last year cleaned almost 10 million square feet. I'm so confident that we have the best machine for you. I'm willing to make you this $10,000 cash guarantee. If you'll commit to buying a water blaster in the next 90 days, and you'll commit to giving us ample time to demonstrate the clear, effective advantages of our machine, I'll give you $10,000 based on one more commitment. Come to Stuart, Florida, see the stripe hog operate, understand the unique benefits, allow us to share with you who our 10 global competitors are, and then you have to visit them and do the same thing. Not all of them, but at least one. At the end of that process, you buy their equipment, you keep the 10 grand. If you buy a stripe hog, sorry, you got to give the 10 grand back. It's our way of guaranteeing you that it's worth your time to take a hard look at stripe hog. Thank you for your time. And if in the end you have more questions, don't hesitate to call me or one of my competent sales staff. Thank you.